Hi, it's John Tommy Rosas. Um, I'm a U.S. Coast Guard certified builder of documented vessels and master shipwright. Have been for about over 40 years, and I'm giving this presentation on for the Fall Marina Interagency Committee and the work group. Um, this whole thing, and the things I want to talk about that are being omitted is the galvanic corrosion on the anti-fouling paint on the vessels. There's also connection with the marina shore power defects and on the vessel's electrical systems. That would be the bonding and grounding. I mean, I have some good information on that. I'm also going into the OSHA and Cal OSHA, US EPA, DTSC, um, safety, pollution regulations, and for compliant vessel anti-fouling coating replacement processes. And also, I'm going into the electrical on the vessels and the marina because they're all affecting the bottom paint. Any bottom paint or anti-fouling paint that has metal is going to be affected. It doesn't matter what how noble the metal is. Really, it's going to come off. And so I'm going to go through this thing. I know there's not a lot of time, and we can discuss it more. But I'm going to provide all the links as we go through this, and I'll make a list and email them as well to Mike. Okay, so my suggestion is they inspect the vessel's electrical bonding and grounding on all voltage systems. That's when the boat's in the water. Inspecting test the vessel at its dock and the surrounding waters. I have the instrument to show you what could be used um, to test for stray current voltages through the various sources. Um, the way to correct it, and there's numerous reports and guidelines and actually regulations on that. And I know from being a shipwright all these years and having to build Coast Guard inspected compliant vessels that in the boatyards I worked in and shipyards, most of them aren't compliant, and it's a problem, including electrocution. And these are some of the reasons that I kind of went over already. Improper grounding, stray electric current. That also involves bonding. Bonding and grounding is two different things. They mix them, and it's a problem. Um, there's improper hull surface preparation and contaminants. Um, that's another issue with these bottom paints. We call them bottom paints that anti-foulings. It's easier to say. But even hands touching it, the finger oils can um, be a contaminant. And there's air contaminant. They use air to blow the hull clean and with high pressure air. That can have oil from the compressors, and that'll contaminate it. Sometimes they use heaters, and in one instance in Seattle, they had that new Micron 22 that came out. That was like, man, I don't know, 35 years ago. No, it was more than that. It was 1977. Yeah, it's like 41 years. Um, the the they had diesel heaters, and it was spraying these nanoparticles of diesel, and it was fisheye the paint. So I figured out what it was, and they quit doing it. But that was for international. The other thing they don't do is there's not sufficient coating thickness. They don't measure it with a mill gauge mechanically, and they should. And they're not requiring the certified applicators like I was for every coating. Um, and so there's no telling who's put these paints on. And sometimes they have these seminars, but the salesmen don't really know either. So, it's a problem. They also miss the overcoat windows for both the barrier coats. That's the epoxy barrier coat that goes on after the hull's all clean, and the anti-fouling coats. There's um, a window that those two have to be put on, and then the those windows are missed, and they either are too early or exceed the times recommended. There's also another issue in the shipyard and boatyards that there's undocumented removal and disposal of the removed coating um, debris, and the non-compliant containment of the coatings removal. In other words, they're not covering the vessel properly, and during the application, and they spray coatings, and that includes top side coatings, we call it, that aren't on the bottom. And I work and live in Marina Del Rey, and when I go by the boat yard, it's one of the yards in the marina. I've seen the dust come out of those tents that they make. They're kind of rigged up, and it actually goes on the state line across the street and pollutes it. So there's an exposure there, and I've got the agencies that have jurisdiction. I didn't put in the air quality, but that's an obvious one. But I put in the other ones more to do with the paint. Okay, so I'm going to jump to the reference materials. I kind of got them lined up. Galvanic corrosion, that's what's burning off the paints. And it's important to understand that because, and this is from NACE.org, they specialize in this. And I'll provide that list of these websites that I got this information from to make this easier, because I'm not a professional presentation person, so I'm just using their stuff to help explain it. But you folks will have the links to go over it on your own time. So they go into the galvanic corrosion pretty thoroughly. This is the one type of solution that most boats don't have on the vessel part. Here shows the current flow with the different noble metals in the water. Let's say there's a bronze or brass propeller, any of these through hull fittings. That current flow is going to go to the other vessel, to aluminum stern drive or any other metals. But also, the boats are electrifying around the vessel itself. So all these vessels, and I can show you the meter that tests it, but all these vessels are burning off their own paint besides creating these trace current and stray current flows to each other. And you can see where the grounds are bonded through to each boat instead of being isolated, and that's the problem. So this is a galvanic isolator, very important to have, and I'll go into the bonding. This is from the Department of Pesticide, the state one, and they talk about all this interaction with electrical conductivity. That's what they call it. There is Coast Guard specs, OSHA specs, and all that to cover that, but they're starting to be aware of it, but they're not connecting it all together like I've done today. Okay, so I'm going to jump to this. Here's the isolator from the Shore Power, which is 3-wire, and it shows the grounds and the ground fault indicators, and then it shows here optional galvanic isolator. Well, that shouldn't be optional ever. That needs to happen. And I know the Marina Del Rey Harbor and Marina's got a lot of issues there. They all of them leak current, and I can see it on the boats. It actually leaves a mark, and it can be tested. I wanted to work that testing out with Michael Tripp of the Beaches and Harbors there, but we haven't got too far with that. This shows the current not balanced and opens or trips the breaker. This shows leaking voltage to the ground. It shows that this is the ground. I mean, this is the ground here, and this is the hot wire that also leaks it. So there's a problem with that. This is a shore power receptacle to the vessel, but there's a lot of issues with electrical now. They don't have proper electricians working on the boats. This is a pretty good diagram of the current code, which the Marina Shore Power isn't code that I can see, and most of them have the old 3-wire, which isn't code anymore. It has to be 4, so that the neutral isn't connected with the ground like it used to be. And even though they don't show it here, it is right here. There's the ground, and it's tied to the neutral. So that's not code anymore. Hasn't been for like 10 years, but they haven't kept up with it. Okay, moving along. This is on. This is a Navy document on interaction with anti-fouling paints and steel. Why that's important is, even though a lot of recreational vehicles aren't steel, some are, but mostly they're not. They're fiberglass and some wood. But the steel is the same kind of component that reacts to the copper, and it can corrode the iron. But it can also, in the same way, through the galvanic action, corrode the paint because it's in a charged anthode cathode situation. So this is a story about the hot marina. That's what you call them when they're not wired right or got some other issues. This shows the current when the AC ground fault isn't working, and it goes through and bleeds current in, and so all this water is charged. This is supposed to be a boat. It's a simple diagram, but this is getting into electrical shock and causes drowning, and that's another important safety issue. This explains it pretty well, that article. This is the one from Boat USA about marina dock safety and electrical shock drowning. It's actually a big problem. This is the E9 is the older electrical system report that's under ABYC. What they recommend is compliance. So I provided that. This is the new one. It's also the one that the Coast Guard uses. This is the Coast Guard copy. And they talk about grounding, currents, and all that, overcurrent. This whole thing's on electrical. And it's a CFR, it's that, but I'm providing that. This is the water board reports on the Marina Del Rey and the amounts of copper and all that. Some of you folks know about it. I worked with Regional Water to get the Marina Del Rey waters cleaned up, which we got approved by the EPA a few years ago. And that's a pretty good report. This is the plume of the copper. Shows the distribution. This is the main channel if you're not familiar with it. And it doesn't really flush well. The original design had the opening of the harbor over here, and it was round. And they wanted to maximize the slip, because this is still the largest man-made harbor in the world. For marinas and all that. But there's still quite a bit of copper in there. These are higher concentrations here, but I'll provide that report if you don't have it. This shows the Marina Del Rey basins. They show about 5,000 slips. It's closer to 6,500, but Michael Tripp would give an accurate number. They keep redesigning it, so we're losing the small boats but getting larger vessels. This is one by paint.org. They talk about the regulatory activity in the state, um, and that's a pretty good thing to look at. Article. This is the EPA, U.S. EPA's um, document on this subject. I'm going to look at the title. Yeah. They talk about the flushing, boat cleaning, and all that. I'll get into the divers and how they're doing illegal 404 discharges. Um, this is from DTSC. Shows how they sand and what they're supposed to use and keep track of, but it's not happening too. It's not too compliant as far as the yards aren't. This is from the Coast Guard. I mean, this is from Army Corps. They actually have jurisdiction, and they have this guidelines book. I'm going to provide that. It goes into the grounding, and but they're not connected to the paints and the other issues. The other issues that happen with this bad and improper electricians doing the electrical work on boats is that they're connecting the bond straps to the grounds, and that's causing the electrical stray currents to burn off the tin and zinc anodes, and that's another pollutant, and it's tons and tons. This is the OSHA. They have authority and jurisdiction as well. So does Cal OSHA. This is on shipyard industry standards, and it should be used in the local shipyard. That's the CFR for it. I'm providing all these links, like I said. This is on shipbreaking from OSHA, but when people do repairs, this same situation happens. It's not just when they break the ship up, but this goes into what's around, including lead, chromate in the paints on the inside of the boat. When the water gets in the boat and it's cooked, it starts cooking this stuff, and the bilge gets pumped out. It's discharging all this interior metal, which is another thing to look at as far as throwing interior metal to the exterior, and then that reacting to the galvanic corrosion. Let's see, where are we right here? This gets in the blasting, which is basically sandblasting, but they use abrasives. This is CFRs on coatings and all that from OSHA. This is on safety on longshoremen and commercial diving operations, all that. Quite extensive. This is the OSHA requirements on marinas, which I know if they went over there, there'd be need to be an investigation at Marina del Rey. This is a DTSC's recommendation on using abrasive materials to blast. They're using soda and different things. It's in a soda ash or something like that, but there it is right there. They use garnet, but they're not. The yards aren't dealing with the stuff that comes off of it. I've seen them dump it in the dumpsters. Okay, this is from Department of Pesticide, and they have quite a bit on that. A lot of you folks are agency people, so you know about this, but I'm just putting it out there. This is an old 1990, I think it was 78 study on copper-based anti-fouling point. There's a really good, lot of good information on that older stuff. This is on the leaching. Excuse me. This one has references on the nano-sized copper that comes off the commercial anti-fouling paint, which is pretty interesting. Even though I'm not a scientist, I do study. This talks about life cycle contributions of copper from vessel painting and maintenance. I have this highlight because this medium duty 3M pad is actually called Scotch-Brite, and it's an abrasive, and the divers, all of them use it, and they're actually sanding the boats underwater. I got pictures of it, but that's illegal. That's the 404 discharge. That being Section 404. Okay, here's another one on in the water hull cleaning. This is from the military as well. This one's from, oh, this is my copy. This is a document that they did a test on all this that we're talking about from the Suez Bay. Now this is the handheld meter for conductivity that you can use in your own situations to test the voltages yourself. And that's what I was trying to get Michael Tripp to buy and let me do the testing. Maybe the state can knock some money loose so we can test the waters. Because if they don't deal with the voltages, whatever we do with the chemical content and the metals isn't going to matter because it's still charged inside and out. This is the manual for it. I'm going to provide that. It tells what it can do. This is from, this is on electrical chemical corrosion in the particles and all that. This is the use. This is from paint.org. This is the copper-based anti-fouling paint. This is a ship's encyclopedia. It's really good. It's done by IMF and the International Treaty, so you can see some of the terminology. Some of you have jurisdiction in the larger shipyards and berthing areas, and this would be handy for you. I actually used to work at Delta Marine, which is a cracker, long time ago. Yeah, this is the IMO. So I said IMF, it's IMO. IMO, yeah. It's the International Maritime Organization. This is another document they put out. Okay, here's the divers standing underwater. And you can see all the stuff coming off. There's a giant one. Here's the Scotch-Brite. So they're grinding it off and it's discharging in the water. You can see the plumes coming off. And some of them have air sanders down there, like this guy. So you can see all the stuff that comes off. The other thing I want to bring up is that all this growth is happening because the anti-fouling quits working after a few months, and everything's grown back on there. And if it wasn't true, then why is all that stuff there? I mean, it doesn't take that long, and it's already growing. We've put boats in the water that people have painted, taking them out, and they already were growing like there was no bottom paint. And this is another, this is about hull resistant management, which includes growth and different kinds of paint. Anyway, I'm wrapping it up. You know, there's a timeline here I probably went over, but I tried to cover all these points, and when this presentation is online and I'm going to attend by a conference call, I can, you know, help answer some of the questions on if there's time. Okay, thanks a lot. Bye.